Good afternoon and welcome to this month's show. I'm Luke McCormack. During today's show, we will be discussing big data in government. With me on today's show are Donna Roy, Executive Director of Information and Sharing, Department of Homeland Security; Tom Sasala, Director Operations and Architect and Chief Data Officer with the U.S. Army; Jonathan O'Neill, Director Big Data Project, NOAA; Brigham Bechtel, Chief Strategy Officer, Marklogic; Henry Sowell, Chief Technology Officer at Cloudera; and Nick Psaki, Principal Office of the Chief Technology Officer, Pure Storage. Well, big data, big subject, big opportunities, big challenges. We got a lot of data to ingest. There's a lot of data being collected out there more than ever. It just seems like it's going 10x, 100x every time we turn around. Lots of issues and challenges and great technology on how we're storing it, flash coming out, et cetera. Of course, we've got to protect it all, and how do we use all that data, right? All this ML and AI that's happening, and a lot of data now that's in the unstructured format, right? It seems like those are where the gems are. So, Donna, let's start with you. We always like to start with just give us a state of where is Department of Homeland Security in regards to big data these days?
Thanks, Luke. We've been working with big data for 3-4 years, maybe, starting with our science and technology guys who gave us some great access to labs and products, learned very quickly that you need to work with real data, live data, in a lab format, and test all of the tools to make sure you know what you're doing. That led into the department's first attempt at a big data lake, a series of lakes called the Data Framework. We're learning from the initial release of those data framework activities a few things, and we're rescoping some of the activities, but we are going fast and strong to make sure that we've got the right analytical tools for our mission operators. And we are seeing a significant amount of importance placed on the data framework by the Hill, who put out a new law saying DHS will sort of make the data framework happen in about 2 years. And so great activities and a lot of hope in making sure that we've got the mission drivers for the right big data activities.
A lot of data coming from a lot of different parts of that community, and only when you have a framework can you put some, I'll say, law and order behind it, no pun intended there, in regards to making the best use of that. Yeah.
The framework allows us to put data in, protect it, and make sure that we've got only the right people accessing it for the right purposes, and creates a platform for us to create an experimentation framework for our mission users so that they can use it quickly, learn quickly, fail quickly, and move on to the next sort of experiment.
Fantastic. Tom, how about over at the Army? I know you guys are collecting a lot of data, incredible amounts of data, getting it out to your soldiers out there on the field, right?
Right. Yeah. So we have quite a number of different projects that are ongoing right now, and I kind of want to step through a couple of them. So about 2 years ago now, the Chief of Staff asked for what he called he was calling the readiness dashboard. He just wanted to get some sense of how ready the Army was, and through that process, he said, "I want access to all the data that the Army has at my fingertips, at my desktop." And so that's a huge ask, right? And so the reality is he doesn't really need all the data necessarily, right? But all of the data required from the business side and from the mission side fused together in one way that is consumable by him and his senior leaders is essentially where we are today. And so two things, so the Army, what is now called the Army Leader Dashboard, right, intended to be used not only for readiness, but for also other types of business decisions, has been piloted for almost 9 months or so now. It's been online and operational. We've got a lot of lessons learned out of this process. And so from there, we're creating not just one, most people say, we're going to create a data lake, right? So we're actually going to break this down into multiple individual data lakes based off of what we're calling information domains rather than parts of the organization or systems, right? And so things like financial management is one of the domains, human capital is a domain, so we're going to try and put all the people data in one place, or all the financial data in one place, or all the logistics data in one place. And when I say one place, it's a logical one place, so it's going to be a cloud-based storage solution that we're going to take from the originating data sources. I don't want to call them authoritative because we've learned that they're not so authoritative over time. So the originating data sources, we're going to curate them, and we're going to cull them in, and we're going to clean them, and then we're going to deem the data lake the authoritative data sources. So that's going to be hugely important to us, and so we're right now tentatively calling this the Common Data Framework. We don't have a snazzy name for it, although OSD is trying to give us one, so we'll see what happens. And then we are actually partnering with the what is now soon to be nominated or named the DoD Chief Data Officer, which is they've got this thing called the Defense Repository for Common Enterprise Data. DERSED. They're also branding it with a new name because the DoD, we have to come up with acronyms. But so what we want to do is we want to take our curated data and feed into their database that they are now fusing data across all the military departments and the services into one kind of big repository. Now, their repository is specifically used for business kind of data, not mission data per se. So what we're investigating is us in the Marine Corps and the Navy, a little bit the Air Force, but can we take our concept of this common data framework and turn it into a tactical thing that we can now in theater create theater level sort of repositories based off of whatever the type of mission data might be. That's a little sketchy because of the disadvantaged, disconnected, sort of limited bandwidth environments in the forward deployed areas. But there's a lot going on.
And I heard framework out of 2 different agencies there. That's interesting. Henry, how about at Cloudera? I know you kind of see across this perspective. What are you seeing across the community as everyone embarks on this big data journey, so to speak?
Sure, thanks, Luke. So very much like Tom was saying, we're seeing a lot of the same thing of, one, how do you collect from disparate data sources, often where data's messy, and then how do you move it into a common area where people can access it and gain insights from it. So one of the things that we've been delivering is, one, from the edge, a collection mechanism, a mechanism to clean and understand, catalog, and make available data into a enterprise data cloud environment. And that's been our primary focus. And we've seen a lot of success in achieving that. So we're starting to see that, I think, a lot more awareness across the government into the need for these items. So a few years ago, you'd have an education about what big data was. Now we're seeing a better adoption of big data technologies, understanding the practices, the pitfalls, and the things that we need to accomplish to make ourselves enterprise class and ready. And so that's been the big area. So we have a number of different agencies where we're having some great effects into that, some that are public, like the work that's being done at Census, marching towards the 2020, that's been a big deal, right? How do we collect at the edge at multiple different collection points, bring that back, gain insights that help shape policy for our entire country.
Sometimes that incredible volume. Well, we've heard about law enforcement, Homeland Security. We've heard about the military. Let's talk about the scientific community. Jonathan, I know you guys are over there collecting massive amounts of data. Tell us about sort of the state of the state. What's happening at NOAA these days?
So 4 years ago,
weather data going, right?
It's good.
Weather models.
It's good.
Yeah, it's good. Great.
So about 4 years ago, NOAA started something called the NOAA Big Data Project. So what we did is we signed 5 cooperative research and development agreements with Amazon, IBM, Google, Microsoft, and an organization called the Open Commons Consortium, which is out of University of Chicago. And basically the goal was to make NOAA's publicly available data available on the cloud. So we have these agreements, the collaborators, as we call them, which are just the cloud providers, agree to make the data available for free. There is an option to charge for what's the marginal cost of distribution, but so far nobody's actually taken, no one's charged for it. So they're making satellite data available for free, some ocean data. There's a variety of different products. So what we've seen, and this has been a good foray for NOAA to just sort of test out the cloud in a way. And this wasn't necessarily the first, NOAA effort into the cloud by any means, but it was organized in a big way,
yeah.
Certainly. And we've seen once we put data on the cloud, we see usage go up. We see innovation happen, particularly with access to some of the satellite data. There's a lot of small companies that are sort of developing around the GOES products, GOES 16, GOES 17, which are both on the cloud now. Also, we see some decrease in the load on internal NOAA systems. People aren't coming to us as much. They're going directly to the cloud to get it because that's where they're computing anyway, so it's just simply more convenient. So we've been going for about 4 years, and we've learned quite a bit.
So you're collecting, ingesting, posting it out there and saying, have at it.
Exactly.
Everyone innovate. That's fantastic.
Yep.
We have to thank our cloud service providers for doing that. Brigham, tell me what's happening at Marklogic. You guys have a fantastic technology that kind of fits in the middle of all this, right?
We do. We're very proud of some of our positions in both industry, manufacturing, and government. We have some nice positions in government that we don't talk about it much, but the one that we really like to tout is we're the backbone of healthcare.gov now. When Health and Human Services was tasked with standing up healthcare.gov, CMS was tasked with standing that up after the act passed. They were given 18 months. They tried to accomplish it with a relational database, and Marklogic basically had to come in and help rescue things because the relational database couldn't work at that speed. We did it within 12 weeks. In average, we were dealing with 8 million people trying to sign up for healthcare insurance in different places. 5 months after, so we did it within 12 weeks. Even after 5 months, you're dealing with 5,500 concurrent transactions in a minute, everybody online. You're talking about 160,000 users in any one time. And after 5 months, and even through today, 99% availability. We've had no problems. And it's that multi-model NoSQL database that allows for you to take in different types of data, different structures of data, different schema and format, and then make it immediately available, indexed back to people. That's one of our strengths, and we're able to do that for.
Fantastic. And you never hear anything about that from an availability standpoint, and there's a lot of instrumentation. I was involved in some of that, and making sure that everything was understood and identified, and that's fantastic. That's a great story, good news story. Nick, how about over at Pure Storage? You guys are right smack in the middle of this movement as well. You're seeing a lot of activity. Tell us sort of what you're seeing out there as far as the community is concerned.
Sure. We know this about the government. For as long as there have been digital systems for collecting data, the government's been collecting data. And at government scale, there is no small data. All data is big data. But the challenges have been, of course, that data is everywhere. Access to it is problematic. We've got silos of excellence. And consolidating that data has really sort of started to become one of the primary challenges. We've heard, our colleagues here have said their organizations are creating data lakes or data hubs or basically a data factory. If you think about it, if an IT enterprise were a car, then Cloudera and Marklogic and the data analytics platforms are the engines. But how fast can you actually deliver fuel to the engine? That's actually, or get the power down to the road. That's actually where the data service platforms, the storage platforms, if you will, come into play. So if they're the engines, we're the tires. And what we've been very successful in doing, especially with large enterprises like the Defense Civilian Personnel Management Office, other customers in the Army, in the IC, Food and Drug Administration, Health and Human Services, and even NOAA, is helping people unlock the value of their data or getting to the value of their data faster by significantly increasing the velocity of data. 4 V's of data: volume, velocity, variety, and veracity. Well, storage platforms are directly responsible for affecting the ability to deal with the volumes of data, which just keep increasing, the velocity of that data, how fast can we move it, serve it, and derive value from it, and then the variety of that data, because we are creating new data types at an astonishing rate. So our job is to help these agencies unlock the value of that data, deliver those data platforms and data products to their supported agencies, and help them unlock the value and reduce the time to insight. Examples are actually pretty tremendous, but one of the things I love about the DCPDS is having adopted a high-performance memory-based storage platform. The Air Force called and said, "We got a problem. Our job's not running. The process is broken." They said, "Why?" "Well, this job used to take 8 hours to run. Now it takes 20 minutes." So when you're trying to plan payroll and leave time and hours for in excess of 1 million people, and you can get that done in 20 minutes, you just put a tremendous number of hours back in people's days to solve other problems.
Some new capabilities, and it's amazing how quickly the technology and storage has changed and kept pace and actually gotten in front of this sort of big data revolution, if you will. Well, let's move over to specific programs. I always like to cite a specific program. Tom, I'm going to ask you if you could start us off in regards to just identifying one program that you guys are working on where it's making a huge difference in regards to the use of this big data, right?
Yeah, so I mentioned it earlier. It's the Army Leader Dashboard. This program has been really a seminal program in the Army to just change the perspective of Army leadership on data itself. We've had big data programs going on for a while. We have a big log program that's been what is known as our hub of log data. That has actually been in development and deployment for almost 7 years now. But it is really the Leader Dashboard program which highlighted not only how much data the Army actually has as we were inventorying it, but the quality of the data. And that is when the Chief of Staff and the Vice and all the rest of them sat around the first demo and they saw the information that was coming to them, and they're like, oh, so, a simple question, how many soldiers does the Army have, right? And we had 5 vendors that were competing for this at the time. And the numbers ranged anywhere from 850,000 up to 2.2 million, which is a pretty astonishing swing from a system that is all based on exactly the same data, right? And so it's not so much about what the data is, but it's the interpretation of the data and the quality of the data and how you integrate the data, right? And so one vendor was integrating not only the existing active duty components, but anyone that had retired within the last 5 years, which is the 2.2 million number, right? And the other vendor was only looking at the current number of soldiers that were deployable today, right? And then in the middle is the actual number, which is around 1.1 million soldiers, right? Which is the deployables and non-deployables minus the minus the retirees. So what this highlighted to us is not only the quality of the data, but our fundamental lack of understanding of the systems that we currently have, the data that's in them, and which one of those fields in the system are the important fields for making business decisions. And so in many cases, we do have data standards and interoperability standards around some of this data, especially the DCPDS data, right? But we don't necessarily know how that data is used. We are duplicating the data unnecessarily, right? So every system that we've discovered so far, every single one of them has a unique identifier for people, which is, in our case, an EDIPI. We couldn't find any that had a PIV identifier in them, which is okay, I suppose we're in our transition stage. But rather than pulling that data from a central authoritative repository saying here's where all the people data is, right? They're replicating that data straight from DMDC into their own system. And then that creates a problem when the replication fails, right? You might get stale and old data. So the integration component in the quality data is really the biggest highlight right there. And it has changed fundamentally. The Undersecretary, the Vice, the Chief, the actual Secretary of the Army are now talking about data and data quality issues and asking questions of their 3 stars and their 4 stars about data, which is just a fundamental change in the Army's approach to data. And it's,
volume of data, but you actually have the quality of that data, right, and making good informed decisions, including how many soldiers there are. I'm glad to hear that because we have several veterans here on the show that want to make sure they've been accounted for. Well, we're going to take a short break and we'll be right back. You're listening to the Federal Executive Forum on the Federal News Radio, part of the Federal News Network. Welcome back to the Federal Executive Forum on Federal News Radio, part of the Federal News Network. With me on today's show are Donna Roy, Department of Homeland Security, Tom Sasala, U.S. Army, Jonathan O'Neill with NOAA, Brigham Bechtel with Marklogic, Henry Sowell with Cloudera, and Nick Psaki with Pure Storage, and we're talking about big data. Let's go over to you, Brigham, and talk about a specific program. We were talking about very specific programs. I know you've been working with a lot of different agencies. Give us an example of a specific one.
So right now we're supporting the Air Force Research Laboratory. And within the laboratory, there are a myriad of organizations that do experimentation, creating data through their work. And it's been going on for years, of course. Well, connectivity has enabled all of those organizations to be able to rely on each other's data to work from to continue their experimentations, to develop the best materials, to develop the best solutions to problems. And they're relying on NoSQL backends, the performance and the flexibility that the NoSQL model database allows for them. The laboratory built a material science collaboration platform called HyperThought. And that allows the scientists to define their own data models, the taxonomies. They get to upload their semantically linked information. And then Marklogic's semantic search capabilities are then brought to bear. And they're able to go through all that data together and collaborate in a much more effective fashion to make those experiments, to make those findings available to each other, to then feed back into the loop of research that goes on there. One of the things that we find too is they have to rely on the integrity of the data. They have to understand that it's governed and be able to know where it's coming from and who has accessed that data. So the metadata features that we enable allow them to have a confidence and a faith in the integrity of the data that they're working from across organizations and across domains.
Really sophisticated, very fine-tuned instrumentation there, it sounds like.
The semantics.
Yeah.
Semantic search capabilities, I think, are critical to people doing research, particularly in a big data environment when you have so many different data sources and schemas and formats coming together. Those links and that link analysis that we're all talking about and we're used to, that semantic search capability gives them that opportunity to bring those results together.
Fantastic. Donna, how about at DHS? I know you guys are working on a variety of projects over there. Can you point to one that's really changing the game over there for you guys?
Absolutely. Since we decided, like the Army, we weren't going to have one big data lake, we're having multiple conversations. The one that we're making the most progress on recently is working with the immigration data domain, in particular around immigration statistics. Now, this one helps us get to evidence-based policymaking, right? And so at one point we had a large statistical effort to get our data and created an annual yearbook of immigration statistics, right? So it's hard to create policy on an annual basis if you really want to drive changes in immigration. So we're taking that data, downstreaming it, loading it much more frequently, and getting the sort of cohorts or life cycle of enforcements across a particular year and life cycle of benefit processing across the year. And so we're starting to see that we can get that on a monthly basis and really try to impact the policy and the decision making around what's happening on a month-by-month basis, as opposed to 6 months after the year ends, where you get statistics, which is the former way of doing business. And so that really drives to what the new evidence-based law is trying to get us to do, which is use the data that you have to make better decisions about how you're managing your business.
And boy, it couldn't be more timely, right? We're all watching the news. We see all the activity going on there, and I think it's really a great story that you're taking, this very fine-grained data, rolling it up so that the decision makers can make good policy choices. I think that's fantastic. Nick, how about over there at Pure Storage? Can you give us an example, cite an example of where you're seeing a real impact being made?
Yeah, fundamentally, what we're seeing, and you're hearing it today, is that agencies are really shifting their architectural model to be very data-centric. They're thinking about how do we build an infrastructure that supports the delivery of data and the translation of that into information and then intelligence so that they can make smart decisions and policy-based decisions that are actually keeping up with the pace of events. So we're delivering tremendous improvement in terms of getting time to insight for our customers and getting to answers faster. A couple of examples of that start from the realm of genomics and genetic engineering. The ability to process gene sequencing and cancer pathology models at speeds that were previously only dreamt of is starting to give us a better understanding example in healthcare policy of how cancer mutates. We do the same things. The funny part about this is intelligence is a universal function. What we're specifically seeking to know varies based off of application and domain, but the cognitive processes and the data management processes that happen are very, very common. So we're seeing customers start to understand the velocity, the integrity, the deliverability, the accessibility of data is really starting to drive how they're shaping their internal IT architecture, both on premises and in the cloud. And what they're looking for is not the ability to deliver IT services, but the ability to deliver data where it needs to be to the customer that needs to consume it, and then of course providing the service on the collection side to providing those customers with a known destination for that data. And that's really at the fundamental infrastructure level. What we're seeking to help customers do is no longer think about whether or not the IT infrastructure can support, speeds and feeds or connectivity, but will it enable the movement and allocation of data where it needs to be to get to the decisions that organizations want to make. So it's a data-centric architecture design approach rather than a component design approach.
Really, this whole revolution has been cracked open with the amount of data that's available and the accuracy now of the data that's available and the tools that are available to, put it into dashboards and do some of these other things, and all of a sudden you're making real-time decisions, policy-based decisions that you just didn't have access to that information. Speaking of which, Jonathan, tell us about a specific, I know there's numerous ones, a specific program over there that's really sort of, opened up maybe the community or what have you in regards to access to this big data information and making it available.
Sure, thank you. Yeah, so the Big Data Project has sort of, I think, opened up the data to a wider community. So I have a few examples.
Opened it up to the world,
Opened
right?
up to the world.
Essentially.
About 4 years ago, they took the NexRAD, which is Next Generation Radar archive, out of the NOAA archive, and moved it to Amazon Web Services. And a group of scientists were able to take the NexRAD archive and use it to track bird migration patterns. They were able to tease that out of the data. They did all the computing on the cloud, and really it was possible because the entire archive was in an area, in a place where you had compute power next to it. There's other examples. Google did a pilot study with our fisheries line office within NOAA using acoustic data to do what they called Google Translate for whales. So they use their algorithms to identify whale species, right? There you go.
On this show.
There's a blog
Translation for whales. I love it.
And it's just opening up the data sources to innovative uses. So what the project really is doing is we're worried more about moving NOAA's open data to the cloud, and then watching some of the innovation that happens on top of it. I mean, there's companies working on doing things like predicting forest fires, micro forecasting, all kinds of economic development around NOAA data. It's happening on the cloud.
Well, I mean, it's so accessible now. All of a sudden, 3 PhD students can use some of these fantastic AI tools that are available and just crank on this stuff and come up with some really ingenious solutions and capabilities, including the one you just described. That's a new one. Henry, how about at Cloudera? Tell us a little bit about maybe a specific project that you're seeing that's really opened up the aperture in regards to use of the data.
Sure. I kind of like to bridge off of what Jonathan was saying, because there's a huge amount of value of taking things out of archive and tape, because you put them there because you think you've already extracted the value, right? And making it accessible in ways that allow for creativity and folks that get a new set of eyes that extract something you never thought possible from the data set that you had. So having things accessible on a new platform is incredibly important. And then I think the next aspect of that is making it enterprise ready. Do you have security and governance surrounding that? Do you have ways to protect your data, to ensure that it's available, that it's also transportable between different cloud vendors, and that it remains an effective tool for a broad audience? One of the effective things that we've seen from a specific example with the joint with JIDO within the DoD, who are defeating improvised threats, we were working very closely with them to help advance their mission set. Right, it's about protecting the warrior on the ground, and that's paramount. And one of the things that they were having to do was they were focusing on how do they maintain an enterprise class platform. And so they were standing alone. We started a partnership with them reduce their O&M costs for just keeping a platform running from 40% down to 10%. And they took that budget, and instead of, it wasn't just reducing the budget, but it was actually reallocating that budget to analytics and data science projects that actually gave them a better insights into the threats that were happening that allowed them to defeat those organizations. So it's a really fantastic win that we're just excited to be a part of supporting that mission.
And a fantastic example of being able to cut costs and then reinvest as well, which is another, basic premises of the new administration, to plow that money back into some of these reinvestments. This panel, like so many others, is sort of leading the forefront at a lot of these activities. And I always like to ask the question about lessons learned, right? Because you're on this journey, you're plowing a path. You've taken some bullets, so to speak, and trying to figure some of these things out. So I want to move it over to lessons learned. Let's start with you, Nick, down there, and Pure Storage, and talk about, what you're seeing out there in regards to lessons learned, good and bad, the things that are real positive, or maybe some things that people ought to be thinking about that you've seen these agencies get into these different traps.
One of the things big data naturally starts to translate into, this is so big we're going to need computers to actually start triaging and making initial inferences about our data. And that sort of leads us into the realm of artificial intelligence and machine learning. And this has been, a pretty tremendous push in the federal government for far longer than most people appreciate, but particularly within the last 3 years. And one of the first things that customers started to discover is that the infrastructure platforms that they have today are not designed to support the sheer scale of GPU-based compute, artificial intelligence, and machine learning capabilities. So it kind of requires a new set of capabilities designed to address massive scale, parallelism, and concurrency. And places where I know we've encountered this are like the Department of Energy, the National Institute of Health, et cetera. But the cool thing about it is the capabilities to address these kinds of new data manipulations and computational problems are coming to market almost at exactly the time in which we need them. And quite a bit of this pioneering work is being developed in places outside the U.S. government. What I'm seeing is that the government has become extremely open to leveraging large-scale AI and machine learning frameworks and capabilities that were pioneered elsewhere. So I'm seeing the new technologies are being adopted, the not invented here syndrome is being mitigated, and government is actively and aggressively seeking input on how to leverage the value of their data with new and emerging compute technologies to get to answers faster.
It's fantastic, and I'm really glad to hear that. Jonathan, how about at NOAA? You guys, it sounds like you've been at this for a while. You're on the big side of big, so to speak. Tell us about some lessons learned as you guys went on this journey.
Sure. Yeah. So what we've seen is a latent demand for NOAA data. We've seen that people, there is a demand that hasn't necessarily been met by all of our traditional means historically. So once we put data on the cloud, we see the usage go up fairly significantly. An example of that is we put the global GHCN, Global Historic Climatology Network, which is a summary weather data set. Put it into Google's BigQuery, saw 1.2 petabytes of query results generated within 4 months, which was like a 30 to 100 times what NOAA would deliver in the same period, right? Wow. Because it's on the cloud, it's accessible, it's in a tool that, it makes it, easy for manipulation and analytics. So that's really been it. It's been about getting the data up to the cloud, letting the various cloud providers' tool sets, operate on the data, watching innovation happen.
Yeah, put it out there and they will come, right? So to speak. Brigham, how about at Marklogic? Can you give us a specific example of some lessons learned out there?
A real lesson learned for us, and I'm going to echo some of what Nick said, is we're seeing the demand for AI, we're seeing the demand for machine learning. I don't think it's going to come as any surprise to the people on this panel. To us, what that means is it's about the data. And simply assembling all of your data in a lake doesn't immediately make it useful to those algorithms that you want to operate.
Trying to figure that out, right?
What we need to do is make sure you've got data with integrity, that's governed right, that's curated properly, that's secured properly, that you can then feed into those algorithms, because by the time you get it through some of that machine, and then if you want to take unstructured data into deep learning stuff, you need to know that the data you're working with is what you want to feed those algorithms.
Sure.
Yeah, so just putting it in a lake, as we've learned, that's not what makes it useful. It's what you do with it once it's there.
About that, how about at DHS? I know you guys went through the sort of the data lake journey, so to speak, and thought through that concept, and I'm sure you got other lessons learned. So you can give us some pointers
We certainly
here.
learned a lot in the first couple of years.
Right.
In particular, the first time you use your data in a big data way, you figure out the quality is not exactly what you remember it or thought it would be, right? And so while cloud's very important for computational process, I still think there's a lack of a focus on ensuring data quality and speed to understanding how fast you need it. And so early we thought we needed near real-time data all the time, 24/7 in this big data lake. Turns out we didn't really need it that quickly, and we should have spent a little more time cleaning it. And the second thing we learned, because once we started to use it, we couldn't figure out what to do with it. It was so bad, right? So the second thing we learned is that in order to stay safe with the data retention rules and keep things safe, we weren't getting the cutoff dates for some of our data, right? And so we couldn't really safely roll data off because we didn't know how old it was, because the data wasn't coming in with a date on how old it was. And so the basic data management functions, in particular if you're dealing with data on people, and protecting their privacy and their civil rights and their civil liberties, it's really important to understand the quality of the data and how you're managing and curating that data. Otherwise, you'll derail any analytical product at the back end. So that was really important. But the second thing I've learned is it's all about the people and the skill sets. And the challenge we're having in the government is gathering those skill sets and building those skill sets, right? And so there's a lot of focus on data scientists. And that's awesome. I love data scientists. I want to be one someday.
Right.
Very, very
Sounds
awesome.
cool, right? And it's important, right?
It takes a tribe of people to keep the data scientists working, right? And so for every data scientist, you need a couple of data engineers. You need a data artist who understands how to actually present the information to executives. You need analysts who understand get the business value out of it. And so while you'll hear a lot of focus on data scientists, there's an ecosystem around that data scientist that we're not recruiting for, retaining, building, or sort of getting out of the universities right now. And it's the biggest challenge that we're going to have. So we can put all of the data we need in a lake, and if we don't have an ecosystem around better use of it and getting the value out of it from people who understand how to buy these services or run these capabilities inside the government, we're going to slow down progress.
Interesting. You need a whole pod of skills to support the data scientist. All right, well, it's a fantastic subject. We're going to take a short break, and we'll be right back. You're listening to the Federal Executive Forum on Federal News Radio, part of the Federal News Network. Welcome back to the Federal Executive Forum on Federal News Radio, part of the Federal News Network. With me on today's show are Donna Roy, Department of Homeland Security, Tom Sasala with U.S. Army, Jonathan O'Neill with NOAA, Brigham Bechtel with Marklogic, Henry Sowell with Cloudera, and Nick Psaki with Pure Storage. We were talking about big data. We were talking about lessons learned in regards to big data. Henry, let's ask you at Cloudera, what are you seeing as far as lessons learned out there? Pluses or minuses, right? You've been across the community now. You've seen a lot of different things there at Cloudera.
Yeah, I think there's, from a plus and minus perspective, if you look at the machine learning AI piece, I think there is a transition out of the science projects and to, I think, Donna and Tom's points, right? When you look at, hey, this is not just a project in some office that it doesn't impact the mission, but this is our mission, right? Like this is the overall broader organization mission that it has to become enterprise ready. So like the data quality, it's huge. You can't make an effective model if your data isn't squared away, right? And so that ecosystem around those pieces have to be in place. You have to have your security to protect those. You know, we support many extremely sensitive missions throughout the intelligence community and Department of Defense. And so if you don't have your security story squared away, you don't have the governance to be able to know when to age things off, when to who to give access to, who not to give access to. It's moot, right? I can make a really good analysis from the data that I have, but then I've breached privacy laws. I've breached all kinds of things. So it's a transition from science projects to enterprise process for data science, for the mission, and so it's just an advancement in that. So we're seeing a lot of change and shift into that, and I think part of that is a going back to fundamentals on some of these pieces, and
some of that maturity back into to some of this activity. Tom, how about at the Army? I'm sure you've got a lot of lessons learned there in regards to the journey that you all have been on.
Yeah, so we've got a number of things, and I'll start off with what we're calling our data hierarchy of needs. It is a patterned after Maslow's hierarchy of needs, right? So everyone wants to get to analytics at the top, or machine learning, or deep learning, or whatever. But you kind of got to start at the bottom of the pyramid, right? Which is really making the data available, knowing what data you have, making it available, and then moving up the pyramid to the accessibility, and then the cleaning and the quality, which we've already covered, right? And then once you have those kind of what I'll call data fundamentals in place, you can start focusing on higher order analytics or better uses of the data. And so that enlightening moment, happened for us through the Army Leader Dashboard program as well. But one thing that we've covered a lot of these topics here on the panel, but one thing that we haven't really delved into too much is governance around the data once you make the data accessible, right? So the data protection comes in many forms beyond just simply encrypting or providing confidentiality around the data. Donna mentioned the aging off of the data, right? And then there's the concept of conception to destruction of the data, right? People often forget that some data needs to be destroyed, right? We actually had a Defense Science Board and our Defense Innovation Board tell us, well, just keep all the data forever. Which is just, I can't even imagine what that would be like to keep every piece of data we create forever, right? Because you can't, to Jonathan's point, you can't predict its uses in the future, right? There's trapped value there you don't know, but good Lord, I mean, we've got a lot of data we create, and not all of it, I think, should be kept forever, right? But predicting those outcomes, so we're writing the DoD data strategy right now, right? And one of the ones is fit for purpose, right? And so the guy who was writing the section is to go, what does that mean? And I'm like, well, what it means is we can't have fit-for-purpose data, right? We can't predict the future, so the data needs to be stored in a manner that Nick mentioned, right, that is useful in the future, right? And then putting a framework, a tangible and intangible framework around the data to manage and govern that information, so we know when it's created, we know when it needs to be archived or rolled off or physically destroyed or digitally destroyed, right? And then the last thing I just want to mention too, because it hasn't really come up too much, is the talent and culture component, right? Our biggest obstacle right now to data, although the quality from a technology perspective is kind of like a 50-year oversight, right? Because we made all these systems and then we forgot that we might want to integrate them in the future, or we didn't think about it at the time. But the culture around what I call data mining, which is hoarding data, right? So keeping your data for you.
Mining, you mean like me, mine?
Mining,
yeah.
That's
Okay.
I guess
New
that's the
type
radio.
of mining.
The air quotes don't work in the radio, do they?
Right. We had originating data sources, and now we have data mining.
Right.
Yeah,
So
okay.
when I was in in the CTO for the Pentagon, right? We called them server huggers. Now I'm going to call them data huggers, right? They're hugging their data and they won't let it go. They can. They have the technology to enable it. They have the interface specifications to enable it. They won't, because information is power, or whatever the reason might be. So there's that cultural barrier that we need to get beyond.
Sure. Well, we just have about 12 minutes, and we always like to talk about a little bit, forecast for the future. Not way out there, not too far out there, just far enough. And I can't touch it, but we can see it. Nick, let's start with you. Tell us, paint a picture for the future. What's it look like in a couple years with all this advancement going on?
I think that we're going to see a radical shift and acceleration in data integration, data sharing, data insight. It's going to be enabled by a number of things that help us address the volume and velocity problems. Very high bandwidth Ethernet networking, protocols that actually reduce the amount of latency or the time to access that data. Tremendous increase in basically bringing the principles and capabilities of supercomputing into the agency day-to-day infrastructure. So this tremendous increase in parallelism, concurrency, scalability, superscalar architectures, the commoditization essentially of very high performance computing, and the principles of disaggregated architecture are all going to facilitate, they're going to be the mechanisms that enable us to collect more data, assess and derive its value faster, and share that information more quickly. And we're really at an inflection point. The things that are happening today are actually going to enable the knowledge processes of the future. So the software frameworks for doing artificial intelligence, the superscalar compute capability, 400 gig Ethernet networking launching this month from Cisco and Arista. These things are solving the bandwidth challenges, the latency and access challenges, the collection challenges, and we've already talked the abstraction layers above that for access control, the sanctity of the data, the cleanliness of the data, the accessibility of that data. Those are all coming together now, and they're really creating a set of capabilities that are going to provide us with insight that we've never been able to obtain before.
Pyramid before you know it, right? Brigham, how about Marklogic? What's the future look like?
I think what we're going to start to see is a lot of the big data and analytics processes embedded into organizations more and more. It's going to be part of how they do their basic business. And from a simple to complex, just material, resource, preventive maintenance type scheduling, the ordering of spare parts and things like that. Those are going to become things that are just done by machines and it's automatically available. We're going to see advances in object recognition for improvement to C4 ISR and battlefield awareness, and certainly we're talking DHS, the border control issue, to talk about that currently. I think we're going to see a lot of technology improvements that use big data sensor management and things like that going on. And then from a leadership perspective, I think we're going to see a change in training and education of our leaders for the future. You're going to need analysts to have some background in big data and data science. You're going to need the leadership of these organizations to have an understanding of how did we get here? How did these machine results, how can I have faith in the accountability and integrity of these results that are telling my organization we should do this, or that are telling me that we need to order that, or that I think there's going to be a change in the education and training of our personnel.
I mean, 2 years ago, data scientist was a $50 term, right? Now it's sort of almost like table stakes, if you will. But it does take an ecosystem to get behind that. It's a good catch. Jonathan, what's the future look like for NOAA, right? Am I going to be able to run a weather model on my phone at some point? I certainly get the extract from it. It's incredible.
Yeah, I think for the big data project, it's more data, more NOAA open data available on the cloud. Probably the two biggest sort of value proposition pieces that NOAA provides is A, the data, but B, it's also the expertise. It's the NOAA scientific staff that surround and curate the data that also provide a very large part of that value proposition. And then it's potentially thinking about moving some of the compute activities to the cloud as well, to begin to take advantage of not just the storage capabilities, but also the compute capabilities.
A lot of compute, a lot of capability. I mean, I would imagine we're going to be able to, buy GPUs by the drink at some point, right? It's going to be a basic commodity, and with some of those languages that you're going to be able to run on top of that, it's going to be incredible. Henry, what does the future look like if you go to kind of paint a picture over the horizon? What do you see?
Yeah, I think near term over the horizon, the things that I'm seeing, you kind of joked just a second ago about the model on your phone, right?
I wasn't joking. I want that on there. The next time you're on this show, I want a model on my phone.
But the reality is that a lot of those models are getting pushed down to your phone, and they're getting pushed down to your devices. Yeah. And I think that what we're going to see in the government is a further adoption of that kind of technology, where models are going to get pushed further and further towards the edge. You're still going to have centralized clusters that are going to be crunching on vast amounts of data to create models and to piece those things out. But then you're going to be seeing those things go out and push, so that decisions are happening closer to the edge, so that the warfighter, that something's happening, they get an automated warning of activity around them, right? Based off of what's going on in their network. I think that's happening. And I also think that, like, from what Tom was saying from a cultural perspective, I think some of that culture is going that we see a lot of the activity that is happening out in the private sector. I think that it's going to start driving some of the activity here in the government space, because we just can't continue to use some of the mining, the my data. It's going to have to be like, we have a mission we have to achieve. There's a lot of passionate government employees that know that they want to go after that, and that I think that we're going to see a cultural shift into opening those arms. And I think we need to continue to drive that.
Yeah, and I think, passionate is a good way of saying that. I used to say, some of the smartest people you'll ever meet are the federal employees that are out there working on a lot of these really thorny projects or thorny issues. The challenge is they think the most important issue is the one that's in front of them a lot of times, and that's a little bit of a dynamic when you're trying to manage that expectation. Tom, how about at the Army? What does a future hold, right? What is the soldier in the field, the general, what does it look like in 3 years when all this data is accessible now?
Right, yeah, so, Henry actually started the conversation. I was going to say edge computing, I think, is where we're heading very rapidly. For an expeditionary workforce, whether it's someone like the Army who is, forward deployed, or even DHS or census folks or whatever, or even the sensors from NOAA, right? And any individual that needs access to compute and storage but is not on the network all the time, either they're completely disconnected or occasionally connected, right? This edge computing and this forward push to put the power in the hands of the users where the user is at the time, right? And then you mentioned, having the model on your phone. So we can push the aggregate of what that model on that edge compute does back as a smaller piece of data than all of the sensor data that's coming in from from whatever the unit might be. So the example of a self-driving cars generates petabytes of information a day. The Tesla cars, right? Petabytes a day, and only a few gigabytes get sent back to Tesla for analysis as a corporate entity. Now, obviously, thousands and thousands of cars all going back to, Tesla is a lot of big data problem, right? But the amount of data that the LiDAR and the radar on one of these cars generates is just, very, very, very voluminous, right? And that processing there on the edge has to happen, right? And so that kind of ubiquitous edge computing for us needs to happen from a soldier perspective. Whether it's something, I don't want to call it mundane, but something well-researched, which is pattern recognition. But mentioned earlier the cat. You can recognize a cat if it's on a white table facing you, and it's trained to recognize that cat. But you turn it upside down, you flip it, and you get all sorts of crazy reactions from the machine learning algorithms today, right? So that's not acceptable on a battlefield, not even close. So how do we train and not poison the well in that edge environment that has the access to the compute capacity? And the last thing I just want to mention is the emergence of broadband wireless communication that is now people recognize the need to have protected wireless communication, right? The military's needed protected SATCOM for quite some time, right, for lots of various reasons. But things like 5G are really going to change that dynamic in the battle space and giving us access to not only broadband so that we can reach back to the enterprise as required, but also being able to leverage that processing on the edge is going to be critical.
Yeah, I mean, things like 5G are incredible, and the tick up in bandwidth capacity is unbelievable. But it was a good catch, because what a lot of people don't pick up on is the security elements that are baked into 5G that are going to be game changers, right? It's really a big deal. Okay, Donna, how about at Department of Homeland Security? If you were sort of look across your landscape and paint that picture, what's it look like? I mean, you've seen this journey, you've been on it in this community for some time, and I know it's sort of going like a hockey stick, so.
So I think that a lot of what the members of the panel talked about are going to come to a head. We are on a pathway to machine learning and artificial intelligence at the department, driven by the speed of transmission of data off of 5G that's coming soon, and the low cost of putting IoT devices that can do AI at the edge is really going to drive a lot of capability that we don't yet have in place. So if you think about zero trust networks, securing access to things like drones, and which drones should be connecting back and sending data and which not, right? And so there's a really complex ecosystem that we need to figure out how to live within. I think the biggest challenge we have is if you compute at the edge, you really have to worry about data quality at the edge, right? And data quality at the edge is not something I think we're even talking about. But I think that we should start thinking much more around smart data that cleans itself at the edge, data that knows it's smart enough to understand, ooh, that wasn't a really good snapshot, but the next one might be. And so you can't think about data quality as it moves into a big data lake right before use. You have to think about it at the edge, understanding it right before its use, because use is right there at the edge. Machine learning AI built onto a very small, lightweight device causes either really good mission improvement or really scary mission improvement, depending on how well you treat that edge device.
Well, I just heard another neat concept, self-cleaning data.
Self-cleaning.
That is pretty incredible. Well, look, we could talk all day about this subject, but we're going to have to leave it for here. I want to thank today's guests for taking the time out of their busy schedules to join us for the program. I'd like to thank the sponsors for Without We Don't Have a Show. I'd like to thank the good people here at Federal News Network that make our program so successful and enjoyable. And most of all, I'd like to thank you, the listening audience that tune in every month. You've been listening to the Federal Executive Forum on Federal News Network.